we've been doing is we've been taking things in what we call factored form, which looks like two binomials like this. And we've converted it into standard form, which looks like this. Okay, and how did we do that? How do we go from factored form to standard form? What method do we use to multiply two binomials? Yeah, the FOIL method. So that's what we did in the last chapter, and that's what you're doing in numbers 1 and 2. But now what we're going to learn today, and we'll keep doing over the next few days, is we're going from standard form back to factored form. And this is what we call factoring. Okay. So looking at number 1, we've got a binomial times a binomial, and they set this up using the area model, right? X plus 5, x plus 2. So we can do our first times first, which gives us what? X times x, x squared. And then we have outer times outer, which gives us? Hey, Uzziah. And then inner times inner gives us? And then last times last is 10. Good. And then how can I take this and write it in standard form? Good. Perfect. Perfect. That's it. Okay. So I went from factored form here to standard form here. Okay. Now let's do number 2. Again, two binomials. I multiply them together using the FOIL method. So we do first times first, which gives us what? This is just a Thursday paper tan. X squared. And then outer times outer would give us? Inner times inner. Good. And then last times last? Negative 28. Now what do? Combine those like terms. So what's 7x minus 4x? 3x. So now I've got x squared plus 3x minus 28. And again, I went from factored form here to standard form here. Okay. So now what I want you to do is look at the factored form and the standard form. What kind of relationships do we see between factored form and standard form? What's the pattern?
First two will always give you square x, and the outsides and the inners will always be the one in the middle, and the two last ones will always be the individual variable.
Yeah, that's exactly it. So we've got our first times first gives us this x squared, right? Sometimes there'll be a number out in front, so we'll call it ax squared, okay? And then we have our outers and our inners added together, right? Like these, or like these. But our outers times our outers plus the inners times the inners will give us that middle term, which we'll call bx. And then finally, we've got our last term times our last term, which gives us the constant term, the plain number, the one that doesn't have the variable on it, right? Does that make sense? So let's do number 4 together, okay? So number 4. So we're going now backwards. We're starting with standard form and we're moving to factored form. So like Tian just told us, we've got our last times our last, the last number times the last number has to end up at this constant number. And for part A, they give us 3. So now I just think to myself, 3 times what would give me 15? 5, exactly. And then I also want to make sure that my outers and my inners, let me use orange, my outers and my inners are going to get me to this middle number. So what's 5x plus 3x? 8x, right? Okay, so what about B? What about B? I'm looking at this last number, and they give me one of them, so I think 2 times what number is going to give me 6? 3, right? And then again, I can check my outers, 2x, and my inners, 3x. Do those add together to get to 5x? Yes, they do. So that works. Okay, but now what about part C? They don't give us any numbers in there, so what do I do? So not the common factors, but all the factors, which is why this little cheat sheet we made comes in handy. So if you have it, you can take it out. I have some of them, but let's just kind of go through. Yeah, not everybody did, but I have some of them. I'm not ready to give them back yet. So we can just do this together. So what are my factors of 24? 1 times 24, what else? 2 times 12, 6 and 4, 8 and 3, and that's it. Would any of these pairs, so all of these pairs multiply together to get to this last number? So we have to figure out which of these pairs can I add or subtract together to get to 11? Yes. So which of these pairs can I add or subtract to get to 11? 8 and 3. Good. So then I have x plus 8 times x plus 3. Do you want to get a paper, Uzziah? There, it's in the Thursday folder. Yeah, I realized I was not in the right headspace yesterday when I was talking to you. Okay, what's the difference between C and D? Yeah, there's this negative 11x. So what do I do here? So look, it already put in the negative for us actually, so we can just put still just 8 and 3. But now I have my last times last is negative 8 times negative 3, which still gives me this positive 24. But then negative 8 minus 3 gives me that negative 11. Isn't this fun? I love these so much. Okay, how about E? What two numbers multiply together to get to 6? 1 times 6 and 2 times 3. Which pair is going to add together 1 and 6, right? But look, I got to get to negative 7, so what do I have to do? Because 1 plus 6 is positive 7. 1 minus 6 is negative 5. 6 minus 1 is positive 5. What do I do? You make them both negative, right? And they put in these negatives for us here because we're just kind of yeah, negative 1 minus 6 gives me negative 7. Negative 1 times negative 6 gives me positive 6. Okay, F. What do I put in the blank space there? Negative 8 would give us, there you go, 2, right? So my last times last gives me this negative 16, and my outers, negative 2x, and my inners, 8x, negative 2x plus 8x, gives me this positive 6. How about G? What two numbers multiply together to get to 4? Yeah, 2 and 2, and what else? 1 and 4. Which pair am I going to use to get to 3? 1 and 4. And I need to get to a positive 3 here, so what's going to be positive and what's going to be negative? Perfect. Positive 4, negative 1. And then what about H? Exactly, positive 1, negative 4, right? So here I have, in G, I have a positive times a negative gives me this negative, but then I have the bigger number is positive, smaller number is negative, so I end up with a positive middle term, versus in H, I still have a positive times a negative gives me a negative for my constant term, but then my smaller number stays positive, bigger number stays negative, so I end up with that negative middle term. Cool? Okay, and then you can jot down something, anything you notice, any pattern you notice, any relationship you see. We kind of already wrote it down up here, but try and write it down in your own words. Yes. Yes. Yeah, so try and articulate that. And I'm not like necessarily marking this right or wrong. I just want you to get practice expressing your mathematical thoughts, right? Because it's easy to just, it's easier to actually do the math problem than to explain what you're doing or why you're doing it. And I think that's good practice for you. So give that a try, and then we'll do number 6 together. 6 is really related to what we've been doing earlier in the week. Okay, so now looking at number 6. Number 6. What did they do? Like, what happened here between part B and part A? What's the difference? Not a double. What would happen if I distributed this 3? Yeah, right? Or I could think about it going the other way. To go from B to A, I factored out the 3, just like we've been doing this week, right? The greatest common factor between 3x squared, 18x, and 15 is 3, right? So if I take 3 out of 3x squared, I'd end up with x squared. If I take 3 out of 18x, I end up with 6x. If I take 3 out of 15, I end up with 5, okay? So that's the difference here on this side. when something like this happens, when we notice that something has a greatest common factor, we can factor it out first, and then we only have to factor this inner part, the part that's in parentheses. So again, same kind of thing as what we were doing before, but I just look at x squared plus 6x plus 5. So I look at that last number, what two numbers multiply together to get to 5? 1 and 5. And I can use 1 and 5 to get to 6, can't I? Yeah, just positive 1 plus 5. So that means my factors then are x plus 5 and x plus 1. I'm not quite sure why they did it like this, but this is just the exact same thing. So, okay. Are we clear on that? Does that make sense? A little bit? Yeah. Okay, let's go over to the other side and we'll take just a little bit of notes in the quick notes section. And then I'll let you do 1, 2, and 3 on your own today. There's another paper up here that we'll work on again tomorrow. So if you're here tomorrow, you don't have to worry about it too much. But if you're not here tomorrow, I'd start working on it today. But for our quick notes, first thing, factoring a quadratic requires finding two expressions that multiply to the original equation. So just like we saw on the other side, we're going from our standard form to factored form. Right, and as we saw on the other side, it might not just be plus, it could be plus or minus. Okay. And then we also want to know if there is a GCF, a greatest common factor, then factor it out first. And then factor the remaining quadratic. Okay. You can also put one more example over here. So when I have something like this, my standard form quadratic, x squared plus 5x minus 14. My first step is to look at this last number and think what two numbers multiply together to get to 14. What two numbers multiply together to get to 14? 7 and 2, and 1 and 14. And then I think, which of those pairs can I add together to get to 5? Add or subtract? 7 and 2. How do I get to 5 from 7 and 2? 7 plus 2, 7 minus 2. So that's a positive 7 and a negative 2. Let me write that down here. positive 7 minus 2 gives us this 5. So that means my factors are going to be x plus 7, x minus 2. Cool? Okay. So now 1, 2, and 3, I'd like you to give them a try. If you're getting stuck somewhere, ask for help.